In 3D geometry, that is three-dimensional geometry, direction ratios are used to represent the direction of a straight line. In the space. For example, let us consider the x-axis, y-axis, z-axis. So in this three-dimensional space, the direction ratios are used to represent the direction of the straight line in the space. For example, the straight line may be in this way, or here, or here, or here, or here, but we need to indicate the direction using this direction ratio. It is actually a scalar value. It means it has the magnitude alone. It specifies the change in the coordinates of a point on the line with respect to a unit change in the distance along with the line in a particular direction. For example, if the point is lying on x-axis, means probably here or here or here or here, exactly on the x-axis. We can call it x1, x2, x3, etc. Similarly, it can lie here or here or here or here. So this can be represented as a y1, y2, y3, y4, etc. Similarly, on the z-axis, z1, z2, z3, etc. So if it is lying on the axis, means it is very easy for us in which direction it goes. But it lies in the space, like in this case of line 1, line 2, line 3, line 4, line 5. So in that case, in order to understand the direction of that particular line, we need to use this direction ratio. Now, these direction ratios, as I already mentioned, it is used to find the direction cosines also. What do you mean by direction cosine? For example, let me consider a particular line. Okay, so I am having this green line. This is point P. So from this, let me say this is the origin, OP. So the angle between the x-axis and OP is called the alpha. Are you able to follow this? So this is alpha. Okay, let me indicate by an yellow angle. This is alpha. And what about beta? It is the angle between the OP. So this is the OP and the y-axis. So this is beta. And gamma is, this one is gamma, between Z and OP. So this is called gamma. So this cos of alpha, cos of beta, cos of gamma, they are called the direction cosine. Okay. So this can also be represented by simply L, M, N. Whereas these direction ratios are represented by A, B, C. And let us consider a line passing through 2 points here. Okay, so 2 points are there. What are those points? P and Q. P is represented as a point x1, y1, z1, and the Q with the coordinates x2, y2, z2. So let me consider that is, here we have got சொல்ல வேணாம்ப்பா, இது ரெக்கார்ட் பண்ணிருக்கேன். Let me consider the y-axis, x-axis. This is x, y, z. Let me consider a line like this. So this is P, this is Q. So the P is represented by x1, y1, z1. x1, y1, z1. Similarly, Q, so Q is here, it is represented by x2, y2, z2, right? So this PQ is in 3-dimensional space, so it can lie anywhere in this space, but it is specified by these 2 points P and Q. The direction ratios of this line can be calculated. So how to calculate the direction ratio for this? It's very simple. x2 minus x1, that is, you have to consider this and this. So x2 minus x1, y2 minus y1, z2 minus z1. So likewise you can find out the direction ratio. So once we have the direction ratio, we can find the direction cosine by dividing each direction ratio by the magnitude of the line segment between P and Q. So now we have these 2 points. Let me consider another example. So here we have point A, point B. What are the points? For A, 1, 2, 3, that is x1, y1, z1. What about this point B? x2, y2, z2. What are the direction ratio? Very simple. x2 minus x1, 4 minus 1, 3. y2 minus y1, 5 minus 2 is equal to 3. Similarly, 6 minus 3 is equal to 3. Now, we need to find out the direction cosine, is it not? So, for which, what we are supposed to do? First, calculate the magnitude of the line segment AB. So, the magnitude of the line segment AB is the whole square root 2 of, okay, x2 minus x1 the whole square plus, because magnitude means we had to consider the scalar quantity, so the whole square root of, the formula is, that is for to find out the magnitude, that is, let me consider AB. So AB vector and its magnitude is given by, how to represent, x2 the whole square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So we can apply. Now we have got 4 minus 1 whole square, 5 minus 2 whole square, 6 minus 3 whole square. So it means 4 minus 1 the whole square means we get 3. So 3 square. And here we have got another 3 square. 5 minus 2 is a 3 square, and this is 6 minus 3, so 3 square. So 9, and what about this? This is also 9. So 9 plus 9 plus, and this is 9. So it means 27. So square root of 27. So this is the magnitude. So what we are supposed to do in order to find out the direction ratio, as I already mentioned, that is, now we have got the magnitude, that is 27, square root of 27. Okay, and what about the direction ratio? So here we have how to represent that. This is A, and what about this B, and this is C. So we have to calculate, I mean, for in x direction. So x is equal to what? The direction cosine along x direction means that is L. Okay, so that is equal to it is given by A divided by the magnitude of AB, is it not? Vector. So in that case A, what is A? 3 divided by the magnitude value here is 20 root 27, is it not? So you can put root 27. So this is the way you have to find out the direction cosine. And what is M? M is given by B divided by AB vector, and that is equal to what is the value of B? That is also 3 divided by, and this is root 27. Similarly N is along Z axis, is it not? That is, this L is nothing but cos alpha, this is cos beta. M, this is cos gamma, that is direction cosine, and this is C by AB, so vector. Now you have got another 3 by root 27. Okay, and if you want you can further reduce it. 3 divided by, you can split it as a 3 root 3. Okay, 3 root 3. So in that case it is 1 by root 3. So in all these cases you can find this as 1 by root 3. So this is L, M, N. Okay.